Okay, so this last one is on evolution. So, fossil records and evolution. Extinct animals challenged common sense understanding of how the world worked. The common sense understanding was that God created an immutable chain of being. Animals should not go extinct. Fossils found in different sediments showed that animals did go extinct at different times, and God thought, and there was a thought that God had many catastrophes that allowed them to be extinct. With the help of geological theories, Darwin thought that evolution was a result of small changes over a long period of time. Early ideas of evolution, Lyell and Hutton. Lyell thought that uniformitarianism, which is the opposite of catastrophism. Theory of actualism is that changes happen geologically, still occurring slowly today. Cuvier found that many fossils of species were extinct, and the fact that some animals were extinct challenged common sense beliefs of religion. He said that God created animals in a chain of being. Was the chain really immutable? Extinct animals disproved immutability, so the thoughts were that the animals died in Noah's flood. And the fossils of extinct animals showed up in different layers of soil during different time periods, so he just assumed that there were many catastrophes caused by God. Lamarck didn't believe species could branch off. He believed in spontaneous generation, life from the non-living. Darwin was most likely accepted evolutionary theory, natural selection. Yeah. Okay, yeah, that's common sense. Features homologous are a common origin but different function, like a hand and a fin. Analogous, they're a different origin, common function. Vestigial features are rudimentary or non-functioning features that are homologous, like no longer needed, like a tailbone. Embryological development, organisms share common ancestry if show similar stages of embryological development. Like all vertebrate animals have gills during development. The theory of evolution, natural selection, yeah. Life is competition, yeah. Genetic variation, species with larger genome have greater possibility for variation. Sexual reproduction is the only way this works. Different alleles cause these differences, like the HW principle. If A little a and A little a mate, offspring will be 25% AA, 25% AA, and 50% A little a. Represented with it's just like expanding A plus B all squared in math. Only works under perfect conditions, so it's not possible outside of the lab. The population has to be large and perfectly random, and allele frequencies won't change. Random change is small populations. The mating isn't random. There's migration, genetic drift. The change of allele frequency, it's uncontrolled. The bottleneck effect is a bunch of people are wiped out. Small gene pool remains that can reproduce with dramatically different allele frequencies in offspring or become extinct. Flounder's effect is some members become isolated and start new population with dramatically different allele frequencies. Gene flow is when animals leave the major group. They reduce the genetic differences. Mutation is the addition of new alleles. It can be beneficial, harmful, or neutral, and will be passed down if favorable. Types of selection, I should know the diagrams. Stabilizing selection, averaging features, extremes on both sides die. Directional selection, favors one extreme. Disruptive, diversifying selection, favors both extremes, averages die. Sexual selection is selection from sexual dimorphism or physical features, mating or courtship behaviors. Specification, there's Allopartic, so species are divided by geographical barrier. Sympartic, the gene pool divides without barrier. And reproductive isolating. And there's the evolutionary path, which is things like phylogeny, anatomical structures, embryological development, and genetic antecedents. I'm going to leave it so I don't have to repeat myself, and that's it. That's biology summarized.